In this video, we're going to look at collisions. In specific, we're going to look at collisions of one ball bearing with another. We're going to pay particular attention to the momentum before and afterwards, and the kinetic energy before and afterwards. Okay, let's have a look at this first video. Notice that the first ball bearing hits the second one, and the second one moves off at the same speed as the first one hit it. Notice also that only one ball bearing moves at a time. After the collision, one ball bearing stops and the other one moves. Now the ball bearings have a mass of 0.1 kilograms. 0.1 kilogram is moving before and afterwards. If they're moving at 2 meters per second just before they collide, they're moving at 2 meters per second afterwards. This leads us to the conservation of momentum. If we work out the momentum, which is the mass times the velocity, we see that beforehand the momentum is 0.2 kilograms meters per second. That's 0.1 kilogram times 2 meters per second. Of course, afterwards we had a 0.1 kilogram ball bearing that went at 2 meters per second as well. So the momentum is 0.2 kilogram meters per second. And this shows us that the momentum before is the same as the momentum afterwards. In all collisions, anytime one object hits another, momentum is conserved. The momentum before is always the same as the momentum afterwards. Elastic collisions. Now this was an elastic collision. The reason this was an elastic collision was because the kinetic energy was conserved or stayed the same. If we work out the kinetic energy beforehand, we take half the mass times the velocity squared. We work out that there were 0.2 joules of kinetic energy. If we find the kinetic energy afterwards, of course, because the mass and the velocity were the same values, we've got 0.2 joules as well. This shows us that the kinetic energy before is the same as it was after. If the kinetic energy is the same before as it is after, we have an elastic collision. Let's just watch this one more time. Note, momentum is conserved and kinetic energy is conserved. Elastic collision. Okay, second example here. The two ball bearings back again. We've got a piece of plasticine or blue tack in between. What's going to happen here is we're going to release one ball bearing that will hit the other ball bearing again. Notice that at the start one ball bearing moved. Afterwards, two ball bearings are moving. That is, the mass afterwards is 0.2 kilograms, while the mass before is 0.1 kilograms. The velocity is 1 meter per second afterwards, whereas for a start it was 2 meters per second. How did I work out the velocity? Well, we go back to this momentum idea. The idea that momentum is conserved. So, if momentum is conserved, the momentum beforehand, as we worked out before, when we let one ball bearing go, was 0.1 kilograms times 2 meters per second, is 0.2 kilogram meters per second. The momentum afterwards also must be 0.2 kilograms meters per second. Remember, in this collision, afterwards, two ball bearings were moving. They must have a mass of 0.2 kilograms. In order to satisfy this equation, to get 0.2 kilogram meters per second, the two ball bearings that are connected afterwards must be moving at 1 meters per second in order for the momentum to be conserved. So momentum before is always the same as momentum afterwards. Let's look at the kinetic energy. In this case, the kinetic energy before is the same as we had in our first example. 0.1 kilograms times 2 meters per second squared is 0.2 joules. However, notice now in the second example, we have a mass of 2 kilograms and our velocity is half what it initially was. When we work out this equation, we end up getting kinetic energy of 0.1 joules. The kinetic energy has decreased from 0.2 to 0.1. The kinetic energy has not conserved, so this is an inelastic collision. Kinetic energy has been lost. Where's it gone? Well, it was used to deform the plasticine or the blue tack, and when it deformed it would have increased the temperature of that, so it would have changed from kinetic energy into heat energy. Let's watch it one more time. There we go. 0.1 kilograms before, 0.2 kilograms afterwards. And they've slowed down at that midpoint. Okay, thanks for watching this video on collisions.